adding something from that AP classroom video that I really liked there was, if you have two functions that are inverses of each other, the following is true. So this is, you can put this at the bottom of page 16. And then if you do the derivative with respect to x of both sides, the left-hand side is a chain rule because g of x is inside f of x. If we talk through our chain rule, what do? We do the derivative of the outside function, keep the inside the same, and multiply by the derivative of the inside function. So writing that out, I would have the derivative of my outside function, keep the inside the same, and then multiply by the derivative of the inside function. And the other side will be equal to 1. So if I want to get g prime by itself, I could just divide both sides by 1 over f prime of g of x. And technically, g of x is the y value, right? Like g of x means the y value on that function, on g of x's function. And the y value on g of x's function would be the x value on f of x's function. But again, the same idea that we were looking at, sort of to simplify this, is that this means that on your original function, the slope of your derivative, the slope of your tangent line, is rise over run. And when x and y change, it becomes run over rise on the corresponding point of the inverse. So with that, we are going to start looking at the inverse of trig functions. Do the three trig functions, sine, cosine, and tangent, pass the horizontal line test? No. So we have a problem. In fact, what we're going to do today is you're going to have some of your CAS rule and inverse stuff explained from grade 11 and 12 trig that you sort of didn't really understand. Some of that is going to be explained by this with inverses. So in order for the inverses of sine, cosine, and tangent to exist, we need some rules so that they'll pass the horizontal line test. And the basic rule for every inverse is that they say, well, let's consider the domain closest to the origin that passes the horizontal line test. And if it's close on both sides, we'll use the positive side instead of the negative side. So first of all, I'll look at, well, I probably have it on your next, before I draw too much, yeah. First of all, let's look at sine inverse of x. And if I was going to draw sine inverse, and you've got it drawn partially here for you, and I follow the rule, I start at the origin. Here I am. Did you know that sine goes through 0, 0? How far can I draw the sine graph until I don't pass the horizontal line test? Up to here. And then this would be bad, right, if I kept on going? Could I go backwards? Yes. Look at, I'm still passing the horizontal line test until I get to here. And then this would be bad. So for figuring out sine inverse, the first thing we do is we say we have to restrict the domain to go from negative pi over 2 to pi over 2. Because if I went beyond that, I wouldn't pass the horizontal line test. Okay. Now, if we had this, and we graphed it from negative pi over 2 to pi over 2, and you wanted to graph sine inverse, all you'd have to do is switch x and y, and you would get the following graph. Some things to notice. Our new restricted domain was from negative pi over 2 to pi over 2. And our range was from negative 1 to 1. Now, on our inverse, our domain goes from negative 1 to 1, and our range, which makes sense because x's and y's are getting switched. That's what inverses do. So domain gets switched with range, and range gets switched with domain. Do you remember finding reference angles? Do you remember us saying when you find a reference angle, you always use sine inverse of the positive number? Because we didn't want you to get confused with inverses. But if you do the sine inverse of a negative number, you get a negative angle. You can see it in the graph of sine inverse. If you do sine inverse of a positive number, you get a positive number. So we've got the properties of sine. I've written them down here already.
Excuse the interruption, Huskies. Just a reminder that our school store will be opened up today at lunch. So go check out lots of great Husky wear and different little things made in-house and out. But please check out the store over lunch hour. Thanks, everyone. Have a great lunch.
Also over lunch hour, if you haven't done it already, is the second monthly math contest. You guys all wrote it in class for the first one. The rest of them happen at lunchtime. Every question you get answered correctly enters you into a draw to win a free lunch. And yeah, so if you did the first one. Also, those monthly ones, after all 6 are done, I take your top 5 contests, and the top 3 people in the school win cash prizes. So, okay. Anyways, back to our notes. So if you can, stay after class and do that contest. The inverse function, sine inverse of x, sometimes you'll see it written as arc sine. That means the same thing as sine inverse of x. And the domain goes from negative 1 to 1, and your range from negative pi over 2 to pi over 2. So here are the properties of the inverse. The domain, the range, we know our y-intercept and x-intercept. And do you remember odd and even functions? An odd function means a double reflection matches up with what it was originally. And if you take the right-hand side of this graph, I reflected once, would go here, I reflected again, matches up perfectly. That's how I know it's an odd function. A double reflection matches up with what it was originally. Next. Okay. We're going to get to our cosine graph in a second, but if you have a function and its inverse, we remember this property. That f of f inverse and f inverse of f of x is equal to x. So, sine a sine inverse of x equals x, but only if x is in between negative 1 and 1. And sine inverse of sine of x is equal to x only if x is in between negative pi over 2 and pi over 2. So you will get questions like this. What is sine inverse of sine of 5 pi over 6? Well, if I did the math, if I did what normally happens with inverses, you'd say the answer should be 5 pi over 6. The answer to this one is pi over 6. All right, that's where we'll end for today. If you're writing the contest, stick around.